Okay, so now we're going to move on to perfect cubes. So when we're talking about perfect cubes, you know, like an actual cube is what? What is a cube? Look at my cute little cube. It's a three-dimensional shape, right? 3D. So when we have a perfect cube, all sides are the same. So if I have 1 times 1 times 1, the volume here is 1. 1 times 1 times 1 is 1. 1 is the smallest perfect cube. 2 to the third power would also be a perfect cube. What's 2 times 2 times 2? 8. 2 times 2 is 4, times 2 again is 8. 3 to the third power would be 9 times 3, which is 27. 4 to the third power would be 16 times 4, 64. That's crazy that 8 squared and 3 cubed are 64, but we could get into why that is with the laws of exponents. 4 cubed, that's what I meant, 4 cubed. 4 cubed, I don't know what I'm saying. Okay, what about 5 cubed? 125. Okay, I don't know that we're going to need other ones other than, oh, maybe 10 cubed. 10 cubed is, anyone know it? Remember from scientific notation? 1,000. 1 followed by 3 zeros. Let me see if we need any other cubes. I don't think we do for this activity. These are the most important ones, okay? And they're not as easy to memorize as the perfect squares. One thing to just realize is that sum and difference of 2 cubes has a formula. It is factorable. So if you were to multiply this out, if you were to, it's actually more than FOIL. It's like FOIL, because it would be A times this, A times this, A times this, B negative B times this, times this, times this. That would be a lot of distribution, right? So I'm just going to go with the formula for a minute. So they're saying A to the third power minus B to the third power. If I find the cube root of A to the third, I'm going to use A here and A squared. So I'll show you how this works. Okay, this one is sum of 2 cubes. If A to the third power is x, that means the third root is x, right? So when we're talking about A to the third equals x to the third. So that means A equals x. And A squared would be x squared, right? Let me center that better. 27 is the same thing as B to the third power is 27. So what's B? 3, because 3 to the third power would give you 27. What's B squared? 9. Okay, so if I use this formula, it says this factors to x plus 3 times x squared. This right here, negative AB, negative x times 3, which is negative 3x, right? So the middle term, negative 3x. Last term, b squared, is plus 9. Just following the formula and plugging those numbers back in. I'll show you another example using the subtract. So actually, I think I'm going to actually do this one E, okay? Yes. Good question. I'll get back to you on that, okay? So here, what number to the third power, x to the third power, x, what variable would give you x to the sixth power? What number would that have to be? 2. Okay. Everyone see that? So that means that A, if we look back at this formula, this one is for A to the third minus B to the third, is A minus B. This is just from the formula up top. I'm just recopying it. A squared plus AB plus b squared. So we know that a is equal to x squared. A squared is equal to, what would a squared be equal to? If I squared this. Yes. And then we already know a cubed, which they gave us, is x to the 6th. Same thing here with y. B to the 3rd is equal to y to the 3rd, right? So what's b equal to? So I'm just identifying what the cube root, right? What number times itself 3 times gives you y to the cubed? Y cubed, it would be y, right? And then b squared would be y squared. Okay, so now we're going to use the formula. Sorry, there's an equal sign here. My bad. Okay, equal. So anywhere I see an a, I'm going to plug in an x squared. So I have x squared minus b. B is y. I'm sorry, I put those in different order, I realize. That's confusing. Is y. And then a squared is going to be x to the 4th plus ab. If I take a and b, and I'm sorry I didn't put those in the same exact order, what's this a times b is going to be x squared times y, x squared times y, and then plus b squared. B squared is y squared. Sorry, that ran into the other one. That's a squared right there. So the main thing is identifying if these are cubes and then using the formula to plug them into the same format. Yes, did you have a question? The signs. In red, right here. So I'm looking at, see how there's 2 different ones? The first one is difference of 2 cubes. So the negative actually goes in front and the positive is in the back. And the only thing that's different about this sign in order to get these, in order to get a positive, is your plus goes to the front and your last is a negative. So the only thing that changes about these 2 formulas, but depending on the signs, is here this one and here this one. Those just swap, okay? We'll try this, and we're running out of time, so try these problems. I'm going to give you some group work to take home. And I wouldn't stress the cubes as much. I really want you to get the perfect square trinomial and the